Alright guys, so this is a review for your 10-1 to 10-4 formative. And I'm going to put the answers to the first 5 at the end of the slide, though I think a lot of you already have them. But we're going to go through the first 6 together. So here you go, number 6. A ball is dropped from an airplane. I'm just going to read the important points. Here's the formula, and the first thing I need to do is just realize what's part of the formula. And h of t is going to be the height, and it says t right there is the number of seconds that's going to take for the ball to hit the ground. So we could imagine that if you throw a ball from the airplane, you have an airplane. Don't make fun of my airplane. And you know, it doesn't really go down here, but you got to imagine that it starts here, but if we were to draw a full parabola, that's kind of where the direction of the ball would go the other way. And if it's dropped from an airplane, it's going to come this way. So that's why it forms a parabola. How many seconds will it take for the ball to hit the ground? So that's when h is 0. So at this point, there's a couple ways that I can solve this. 0 equals negative 4.9 t squared plus 490. So the first thing I could have done is I could have graphed this on my calculator and found my zeros, that point right there, did left bound, right bound, and found this point. But the way that I'm going to do it is I'm going to use my calculator to actually use the quadratic formula. So in this case, A is negative 4.9. B, it doesn't have a B, there's no x term, or I'm sorry, t term, so that's 0, and C is 490. So negative B would be negative 0 plus or minus the square root of, and then it's B squared again, which is 0, minus 4 times A times C, which is 490, all over 2 times A, which would be 2 times a negative 4.9. So first of all, I want to do 4 times 4.9, and it's a negative times a negative times a positive. We're going to get a positive answer. So 4 times 4.9 times 490. Get an answer of 9,604. Zero plus or minus over, and then 2 times 4.9 would be negative 9.8. So now I'm going to get up, this is square root. Now I don't think 9,604 is a number that is a perfect square. Let me just check. Second square root, second answer. Oh, it is. I'm sorry, you get 98. So we could break this down into 0. I don't have to write the 0. We have positive, what was it? 98 over a negative 9.8. And you have a negative 98 over a negative 9.8. And here you're going to end up with a answer of negative 10. And here you're going to end up with an answer of 10. Let me just double check that. 98 divided by 9.8. Yep. So here, it's going to be positive 10 seconds it'll hit the ground. And the reason why it's negative 10 is because you really started off the ground. This was right here at when the problem started, which was 0. So the answer would be 10 seconds. And again, you'll get the same answer if you graphed it. Number 7, a carnival game involves striking a board with a hammer that forces the ball up a tube. So you know that game where you hit the thing and it goes up the tube and goes down the tube. And you're trying to get it up to here so that it rings the bell. Maximum height of the ball. So this is actually going to be a problem, not quadratic formula. We're going to use our equation. Instead of h of t, I'm just going to make it y. Before I do anything, remember, check to see if you can actually reduce this, simplify this equation. You can't. So the maximum height of the ball, that's going to be this right here. Now, there's a couple of ways that I can do this. First of all, I can go onto my calculator, and I can do the maximum function, do left bound, right bound, and you'll automatically get your maximum. But I'm going to do this by hand because I know the maximum is the vertex. And the equation for the x-coordinate of the vertex is negative b over 2a. So if this were a test, I'd probably do this way, just find it on the calculator, but I just want to show you that it works either way. So negative b over 2a would be negative 32 over 2 times a, which would be, this is a, 2 times negative 16, which again is negative 32. So you end up with a positive 1. So if x equals 1, the maximum height would be what the y is. So let me go ahead and plug a 1 in to this equation, or this equation, and you get 1 squared is 1 times negative 16 is negative 16 plus 32 times 1 is 32 plus 3. So negative 16 plus 32 is 16 plus 3 is 19. So my vertex is at 1 comma 19. So I know that that is the maximum height of the ball, 19 feet. Number 8, for what values does this function? So right away, I see that this is in vertex form. Have 2 intercepts. Well, vertex form, this is going to tell me where my vertex is. So remember, the number inside the parentheses is where it translates left or right, but it's always the opposite. So this one says negative 1. So I know that my vertex is actually over positive 1. And this number tells us that my vertex is up 3. So my vertex is at 1, 3. The other thing I know is that for this to have 2 solutions, my parabola has to go downward, which means it doesn't actually matter what the number is for a, but in this case, I just need my a to be reflected. So pretty much any negative number is going to work. Because whether it's a skinny or a fat dilation, it's any negative number is going to make it go downward, which is going to make it have 2 solutions. Number 9. Look at the equation below, which equation has no real roots. So real roots, remember, are there solutions to these. Now, no real roots, remember, is if you use the quadratic formula. First of all, if you graph it and it doesn't hit the x-axis, that's how you know it has no real roots. But since I don't really want to go through and graph each of them, I'm going to go ahead and remember that in the quadratic formula, the b squared minus 4ac is the discriminant. And if this number is negative, that means the quadratic's not going to have any real roots. So I'm going to take the first one and do b squared, which would be positive 49, minus 4 times a, which is 3, times c, which is negative 9. And I'm going to multiply all of these together, keeping it as a negative 4. Negative 4 times 3 is negative 12, and then negative 12 times negative 9 is actually going to be a positive answer, and it's going to be 108. So you have 49 plus 108, because it was a positive 108. So I now know that the number of my discriminants can be positive. So this one I know has 2 real roots, so equation 2 must be the answer, but let me just double check. Negative b would be b squared is negative 13 squared, which is 169. Minus 4 times a, which is 5, times c, which is 12. Well, if you multiply all these together, you're going to get a negative 20 times 12. So you end up with 240. So you're going to have 169 minus 240, which is going to get you a negative answer inside your discriminant. So this is the one that has no real roots. And then it says solve the equation that has real roots. So let me go ahead and erase this real quick. So again, if you wanted to, you can graph this to show the roots. You can factor. Actually, I'm not quite sure if this is factorable. I'm sorry, this one is factorable. But I'm not even going to try because the quadratic form is so much easier. Just writing my quadratic formula so I remember. And then also I'm going to make a little note that a is 3 in this problem, b is negative 7, and c is negative 9. So we have negative b, which would be positive 7 plus or minus the square root of b squared 49 minus 4ac. So it's negative 4 times a, which is 3, times c, which is negative 9. And we already found out that this part of the equation was equal to 108. So I have 49 plus 108. Which is 157. So I have 7 plus or minus square root of 157, which I'm going to leave it in there because it's not a perfect square, over 2 times a, which is 6. So this breaks down into two problems. My two problems are 7 plus the square root of 157 over 6, and my other solution is going to be 7 minus root 157 over 6. And you can notice there's a graph here because it says if you choose to, because remember, you could have answered this by graphing, but instead I'm going to use, again, the quadratic formula. So I got 7 plus root 157. And then I'm going to divide that by 6. And one of my answers is about 3.25. And my other one is 7 minus 1 root 157. Enter, divided by 6. And the other answer is about negative 0.92. Negative 0.92. And those are the problems. Here are the answers to the other ones if you didn't have them already, just to double check. And guys, remember for the test, you're studying everything from chapter 10.1 all the way to chapter 10.4.